It's the first problem on the homework page. Yeah, you see the F2 generation has got 630 and then the 490 white. 630 purple, 490 white.
So look at corn. You know, on an ear of corn, each seed is the product of one fertilization. So you got a whole population of genetic cross on one ear of corn. All right, now some of you, sometimes who've seen Indian corn, where on one ear you got all different kind of colors. That's because different pollen fertilize the egg for that one seed. And so you get depending on what that color is. So in this scenario, let's say we're talking about corn. We're talking about, let's say the corn is had white kernels. It's crossed to a white kernel. And the F1, all the colors were purple. So this white came from, let's say, Iowa. That corn came from Iowa. And this one came from Wisconsin. And we crossed them in all the ears. All the seed were purple. Then they produced an F2. I mean, crossing two purple. What was the numbers I gave you?
You gave us 630 purple and 490 white in the F2 generation.
Now that's not a 1 to 2 to 1 ratio.
Well, that's like a 9 to 7.
So right,
is it
right
a 9 to
away,
7?
I'm gonna get there.
Okay.
Right away, you know it's not a monohybrid cross.
Yeah, he did it in class this morning.
Yeah.
Dr. Wang did it in class this morning. It was a 9 to 7.
Right.
9 to 7
He didn't
ratio.
explain it. You can go ahead.
Yeah, because we still need help.
Okay, good enough. That's my favorite problem. This is what you're gonna be dealing with on my final. So it's not a 1 to 2 to 1. So obviously it's not a monohybrid cross. So it must be a dihybrid cross. And usually the question is, what's the genotype of the white and the white? Because all monohybrid crosses, when crossed with two parents, at F1 to F2, give a what ratio? 1 to 2 to 1. This is not a 1 to 2 to 1.
Just by looking at it, you know it's not 1 to 2 to 1.
Well, number one, I ain't got three numbers.
Right. Oh.
And I can look at the numbers and say it's not 3 to 1. Right?
9 to 7.
Yeah. But how do you know it's 9 to 7?
Because the 1 is actually figured in with the 6, the 3 and the 3, which give you 7. Because that one particular one has some sort of, what was the word he used for it? Started with an F? Friends?
Okay, so if it's a dihybrid ratio, because it's obvious not a 3 to 1, right?
Right.
And it's obvious not a mono, because that's not 3 to 1. It's not a 9 to 3 to 3 to 1. So we can do the same thing we did with the monohybrid cross. If I add those up, what do I get? 1120.
1120.
I can't divide by 4 because it's not a monohybrid ratio. So what will I divide by?
2. Divide by 2.
I thought it was 16.
I guess 3. I don't know.
You get 16 squared.
Okay, 16 squared.
So you got to divide by 16. Right? Does everybody understand that?
Yeah.
How do you know it's 16? That's one.
If I cross this with, if I cross big A with little a, my F1 is going to be big A, little a. My F2 is going to be big A, big A, little a, little a, little a. That means if I do my Punnett square, I have to do a monohybrid cross, right? But if I do a dihybrid cross, it will be big A, big B, cross to little a, little b, little b. Right? And F1 is going to be big A, big B, little b. Now you got to cross two of these. Right? Okay. If I cross two of those. And that's when you have to do this. You understand that? That's right. So, let me digress because I feel like I should go through this. Let me do big A, little a, cross to big A, little a. I'm crossing two of these. Let me cross big B, little b with big B, little b. What I want to show you is an easier way to do a dihybrid cross rather than this. Okay? So when you cross these two together, what do you get when I cross these two? Okay, so okay, so I get one big A to two big A, little a's to one little a, little a. This one I get one big B to two big B, little b to one little b, little b. So I could cross both of those together and I would get, I'm saying the easiest way is to cross the A's together and the B's together. Now I want to take this one and actually cross it with everything across the top. That will give me one big A, big B, big B. Two big A, little a, big B, big B. And one little a, big B, big B. Can you follow what I just did with that first one? Everybody's okay with that? Now we're going to take the second one, this one here. And I'm going to cross this one with everything across the top. That will give me, question,
Keep going.
two big A, big B, little b. Four big A, big B, little b. And two little a, big B, little b. Did you follow how I did that? Is everybody on the same page? So I did this one across all the top, and I did that one across all the top. Now I'm going to do this one across all the top. That will give me little a, little b, little b. It will also give me, let me start like I did, take that one against the first one, so it'll be in order.
Right.
Okay.
Big A, little b, little b. Two big A, little b, little b. And one little a, little b, little b. If I count all the numbers up, it'll be 16.
And that also separates all the pheno.
I don't have to go find, where's that other one? Because it's already there. I got 4 ones. I have 4 ones. All the ones are homozygous. Meaning big A, big B, little a, big B, big A, little b. I got 4 ones. They're all homozygous. I have 4 2s, and I got 1 4. But they're all there. Okay? And when I do this, 16 into 11, 20, what does that give me? 40? 70?
70?
Yeah.
Wait.
No.
Yes, you do. You did 70.
70.
Hold on.
1120 divided by 16.
I did that on my calculator.
Yeah, you're right.
Yeah.
Okay, at any rate, that's why you divide this total by 16, because you got 16 squares in a dihybrid cross. Okay? You know, I told you when you cross this, you got 4 squares. When you make a dihybrid cross,